So here, first of all, we learn about data, and then what is statistics and important definitions which is used in statistics as well as mathematics. And these are the basic points to learn about statistics and mathematics. So what is data collection? Data are the collections of observations such as measurements, genders, or survey. Data is raw facts and figures, and which help you to calculate and conclude about important results about some population, or you have to analyze something from data. So data are the raw facts and figures, but data is very important. Data can be any number, any names, or anything else. So a single data value is called datum, and datum does not see very much use. When for example, you want to know about your friend's color choices in your class. First of all, you ask your one friend and what you like, and he say he like blue, and now you stop to answer other friends, and this single collected value is a data, but it is single value, that's why it is a datum. Or if you collect more than one person's information from the one person, or from the one number of raw facts and figures greater than one, so then it is data. Datum is a singular or one value of data, but it is very rarely used, because single value of some raw and facts, single raw or single fact does not help to analyze something. And for the purpose of analyzing and for the purpose of conclusion, we have to collect data. So that's why these raw facts and figures and collection of our observations and measurements and genders or a survey are very important. So the science, what is statistics? We learn when we heard the word statistics, we have a idea in mind about that. Statistics means stats, means some measurements. So now see what's the definition of statistics: science of planning studies and experiments, obtaining data, and then organizing, summarizing, and presenting, analyzing, and interpreting those data, and then drawing conclusions based on them. Okay, so here we have to summarize the data in statistics. Statistics is the science, and science of what? Science of planning studies. In this, we have to plan something on the basics with the help of some collection of data, and on the basic information. Obtaining data, we obtain some data, we collect some data, then organize and summarize according to our needs. Then present mean we present it into chart, we present into a graph or anything which helps us to analyze. So our analysis, according to our analysis need, our presenting slides also change. So presenting, analyzing, then after presenting data into graph or charts, then you have to analyze from it, and you have to the skill to read graph or chart or some summarizing table to conclusion about the data, and interpret those data, and then drawing conclusions. So for the sake of conclusion, we have to adopt all these steps, and all these steps are in a sequence. First of all, you obtain data, then you organize data. These are sequence wise steps. I arrange these steps in proper sequence, and organize data, then summarize data, then present, then analysis, and at last we will arrive at conclusion. So in the basis of conclusion, we make decisions. So population, what is population? When we hear about population, you read the word population in your English book and other books, but here in statistics, population is the complete collection of all measurements or data that are being considered. For example, you have to investigate it about your school student study routines, then it is upon to you. You have to question all the students one by one in your school, or just some selected students. Ask the questions from some selected students and analyze their answers and make conclusions about the study timetable. Then it is totally upon to us. But if we make questions and if we collect data from all the elements or all the points, then this is a population. So population yearly is a large amount. For example, if you have a class of 100 students and you want to know about their timetable, then these 100 students is in your population. And a census is the collection of data from every member of the population. If you collect data from every member, go to one by one, collect data from every member, then it is census. A sample is a sub collection of member. A sample is a sub collection of member selected from the population. Here I say, if you for the sake of your time saving and for the sake of your energy save, you have to collect data and sample from the population, and just some chosen person and particular persons or some particular points you have to collect the data and then analyze it, graph it, and then make conclusions on the basis of that sample. Sample is really small, but sample have the chances of error, because we have to assume is some particular persons instead of the whole population. That's why our sample make an effect on our results. And next we see learn more about sample. Here we have one example, and in US they collect data from 1013 adults and observed and surveyed. From surveyed mean they go to 1013 persons or adults one by one and ask their question how they identify theft. So and on these observations they conclude a result that 66% of the respondents worried about the identity theft frequently or occasionally. So 66% is here is our conclusion, and this conclusion is the last step of our analysis. So here I see 1013 adults with basics of, we conclude 66% of our results, and conclude that on this stat we conclude 66% of respondents worried about identity theft frequently or occasionally. But another person organize this same survey of identity theft, but here he have changed the number of persons. First of all, we collect some sample from all the population, but the second person collects some collect information from all the population, and this is a very large number of these, and then he conclude that the our identity theft is more greater than. So who surveyed? The objective is to use simple sample data as a basis for drawing a conclusion about the population for all adults, and methods of statistics are helpful in drawing such conclusions. Means we have two ways to reach our analysis. First of all, you have go to person by person of all the population and survey and collect data, make results on the basis of them. But of course, if you have a town or some large population, then it is very difficult and time taken task. So for the sake of your time and energy, you have to calculate some you choose some particular persons and then ask the questions from them, analyze their answers and make a conclusion. But this conclusion can be valid from the whole population. Either it is time saving and energy saving, but sample, how we collect sample, how we choose particular sample is the main question. The particular sample or the particular choice of the person can affect our that analysis results, or sometimes our analysis results go opposite. Mean when we conclusion, when we ask questions from the whole population or survey, and our results are becoming totally against our sample questions, then it is very important to questions, or it is very important to choose some particular data in a proper sampling method, not by educated, not by blind guess. Okay, so here there are three terms are most important, and these three terms are prepare, analyze, and conclude. Now I explain all these terms one by one. For example, prepare mean you know uh, how uh, how many ways you have to collect data, how you collect data, where you collect data. Prepare mean you have a clear concept why you collect data, and ask the questions from people according to your result needs. For example, if you go to your class and ask their study routine, but when you are start asking questions from students, you forget your what you ask, and you instead of study routine you collect information, their color, their other choices, then you go wrong direction. Then it is very important to prepare and make a sketch what you want and what you have. So that in that basis you have to prepare a plan, prepare something, a strategy about data, how you collect data, how you arrange data, and how many ways you collect data. So this all these steps are included in our preparation. So next we analyze data. So next we analyze data, and analysis, in analysis we arrange data in a proper graph and chart, and then or put the data in proper table, summarize it, and apply some statistic on it. And some statistics mean formulas, and apply some formulas on it and meets results of. Then this is the last step, and the last step is conclusion. Conclusions based on our on these two steps, and it is, you can say, conclusion dependent on analysis. If you analysis in a right direction, then your conclusion is right. Okay, so these steps remember in mind. These three terms are very important in our conceptual point of view, or in statistics and also mathematics. So next we see one important definition: voluntary response sample. What is voluntary response sample? A voluntary response sample or self-selected sample is one in which respondents themselves decide whether to be included or not. This is very important. I say sample depend our conclusions. If we choose sample method, then our conclusions depends on our sampling, and sampling method is very important. And one of the major and most usable sampling method is voluntary response sample. And you analyze, and this sampling method you already seen in your in online, and when you use online portals, YouTube and Google and Facebook and other social media, sometimes you have a survey on your screen, and you have the right to skip it or to adopt it. It means you have the complete right to if you want to give your feedback, if you want to give your answer, then you can. If you want not, then you will not. So this is self-selected sample, mean the person have the right to select some data and to give answer your questions. But this voluntary response sample is very easy, but it harms our results. See how, in which the respondents themselves decide whether to be included. For example, in that polls in which people online can decide whether to respond. For example, in internet polls, and in internet we have clearly right to answer online survey questions or not. So it is totally depend on our willpower. So it is self-selected. We select ourselves for some particular type of data, and if we not want, then no problem, move forward. Mail-in polls, in which subjects can be decide whether to reply. Telephone call-in polls, in which newspapers, radio, or television announcement. You notice in television when some important interview of some important person or some important show start, then they say call me on this number and they give number. So these are the important. We have to write to contact on this and or not. So this is the self-selected sample. So this is one of the major example of self-selected or voluntary response sample. Ask that you voluntarily call a special number to register your opinion. So next we learn about two and nature and as well as basics definitions, or on these definitions all other stats depend. So first of all, learn it carefully. For example, parameter and statistics. And a parameter, what is parameter? See the definition of a parameter. A parameter is a numerical measurement describing some characteristics of a population. A parameter, what is parameter? A parameter is a numerical measurement describing some characteristic of a population. When you make results with the help of population and you questioned one by one on every person and make a survey and make some conclusions, and you want to apply formulas, then those formulas, those numerical measurements are parameters. And when you choose some sample from the population for the sake of your energy and time, then you have then also you have to need some formulas to analyze it, to make conclusions about it. But now these formulas are called statistics. So you clearly understand statistic. The word is for sample and parameter for population. So word P and P is a keyword. P for population and P parameter. And here same is sample and statistic. So SS and PP we can write, we can learn or remember these two definitions. So now see example types of data. So we have two types of data. One is qualitative and other is quantitative. Data is the raw facts and figures, and which is very helpful, and which is the basics of our conclusion. So here we see two types of data. One is qualitative and one is quantitative. And qualitative and quantitative definitions at some extent can be shown from its name. So qualitative mean quality and quantitative mean the quantity of something. So see its definition. So qualitative data is non-statistical and is typically understand unstructured or semi-structured nature. This data is not necessarily measured using hard numbers used to develop graphs and charts. Instead, it is categorized based on properties, attributes, labels, and other identifiers. Qualitative data is non-statistical and is typically unstructured. Mean qualitative data is unstructured, unsummarized, and the data is not necessarily measured using hard numbers and used to graphs and charts. And instead, it categorized based on properties, because it depends on qualities. And what is the quality? How much important? How much intelligent and intelligency, tallness, beauty, and some qualities. And qualities may be good or bad. And so attributes and labels help us to identify and organize it. And some proper tables, some proper formulas need not these quality data. So quantitative data contrary to qualitative data, quantitative data is totally opposite to qualitative data. Quantitative data is statistical and is typically structured in nature. So these are numbers and structured, meaning it is more rigid and defined. This type of data is measured using numbers and values. For example, you want to conclude about numbers of a student. So you have a data. Roll number 1 student gained 49 marks, roll number 2 student gained 56 marks, roll number 3 student gained 80 marks. Then all these data are the some numbers and values, and on which you have to conclude about percentage of your class. So that's why, which makes it a more suitable candidate for data analysis. So types of data can be shown with this picture. What is quantitative data? Mean examples of, now we see examples of data. Quantitative data. Now, so quantitative data, 3 feet tall, 100 feet pounds, and 15 books on it, and 3 shelves, 2 cabinet, and $15, $100. So these are the quantities: 3 feet, 100 feet, 15 feet, 3. So these are the quantitative. And in the same example, I put the same example from other, but all these two examples have quality and quantitative data, and it totally depends on our point of view. For example, we see the bookshelf is 3 feet tall. Here 3 is numeric value, it is a rich data, and it is defined, and so 3 is quantitative data. And but tall is quality of this bookcase. So tall is the quality. Weight of 100 pounds. Here 100 is reached and defined, so 100 is quantity, but weight is its quality. 15 books on it, 15 is quality, and books on it, it has the bookshelf or bookcase have books, it is her quality, it is its quality. So 3 shelves, and these are, now you clearly make a sketch, qualitative data and quantitative data. So now we see difference between qualitative and quantitative data. So qualitative and quantitative data, basis for comparisons. First of all, we see definition. We see definition of qualitative data, and qualitative data is information that can be expressed as a number. And quantitative data means quantitative data is data that can be expressed as a number or can be quantified. So there, from these definitions, we make clear sketch about these definitions. So can data be counted? Qualitative data, no. And quantitative, yes, because quantitatives are numbers and numbers can be counted. But qualitative, how tall, intelligence, tallness, or any other qualities, wise, poor, rich, these qualities are not measurable. So that's why qualitative data is not counted and quantitative data is counted. Yes. Type of data. So words and objects and pictures, observations and samples, or in quantitative data, the numbers and statistics. So here we understand what is difference between qualitative and quantitative data. So here as you know, we learn basics of statistics and mathematics. So this now we study about linear algebra. Linear algebra definition starts from matrix. Matrix are rectangular array or a formation of a collection of real numbers, say 0, 1, 2, 3, 4, and 7. Means you have the numbers and you have to arrange in rows and columns and put bracket and matrix and inside it, and to close these numbers in a bracket. Then this is the our matrix, and the matrix can be any numbers and small letters. As you know, every person can be identified by its name. Similarly, we have to write the matrix by its name. The names can be written by any capital letters, and these capital letters are totally depend on our wish. We want to give this matrix the name A, and if we want to use the matrix name B, so no problem. So linear algebra, why we study linear algebra? Linear algebra, you have the answer why we study linear algebra at the end of this lecture. So be attentive and listen lectures. Example of matrices: 1 2 3 1 2. I say you have the numbers and enclose it in brackets, then 1 2 3 is a number, and you have to enclose in it bracket, then the resulting point or resulting product is our matrix. And you have one is number, you enclose it in a bracket, then it is a matrix. You have a number and enclose it is a bracket, then it is a matrix, and this is also a matrix. So as you know, every definition or concept have also some types. So similarly, matrices also have many types. Matrices can be identity matrix, matrices can be a null matrix, matrices can be square, rectangular, and many other matrices. So here you see these matrices contain all the zero elements. So this is null matrix, and this is identity matrix because it has only one identity element. If the matrix contain, for example, this is identity matrix in two forms: 0 1 1 0. It has identity elements, and this is also identity element. These are the rows of this matrix, and these are the column of this matrix, and we write the order of this matrix is 2 by 2. Okay, so the matrix can be rectangular. If the number of rows, we suppose number of rows, or give the number of rows m. Okay, let's a matrix, we have a matrix and it has the rows m rows, and we have a matrix and it has columns, or these columns is equal to n, and when m greater than n, okay, when m greater than n, then it is rectangular matrix because number of rows are greater than number of columns. Or when m is equal to n, number of rows and number of columns are equal, as in this case of matrix here 2 rows and 2 columns. So this is our square matrix. So in square matrix you need 2 number of rows, and in rectangular number of rows can be greater than n, can be less than n, or in other words, number of rows does not equal to number of columns. It can be less than or it can be greater than. So this is the rectangular matrix. So similarly we have other some definitions, but these are some important definitions relating to matrices. That's why I define it first. So next, see, this is the matrix form. We can write a matrix in this form or in this form. You have your wish to write this bracket and this parenthesis. This is also a matrix, and this is also one way to write matrix. These are 2 5 3. These are the rows of these matrix, and these are the column of these matrix, and this matrix has 3 rows and 4 columns. That why we write it 3 by 4. And these matrix similarly have 3 rows and 4 columns. So just here the difference is the parentheses or brackets. This is a square bracket and these are the parentheses, and we both are right in the matrix point of view. You have to write this or this. So rows and columns. Rows, all the entries presented in a horizontal way are called rows and denoted by m. Mean all the entries are arranged in horizontal, means these six or 10 are arranged in horizontal. 5 and 3 are arranged in horizontal. 0 and 2 are arranged in horizontal. That's why this row 1, this is row 2, and this is row 3. Similarly, 6, 5, and 0 presented in a vertical way. Then so that's why it is called column, and this is also column. Now I write one example, and you have tell me what is row and column. For example, we have A and B. The matrix can be include alphabet, not necessarily numbers, but in a bracket and small letters. So how many rows this matrix has, or how many columns? So here horizontally arranged, this number is horizontally arranged, this number is horizontally arranged, and we horizontally arrange two numbers. That's why it has two rows. But vertically we arranged one column. That's why it is one column. So it is row by column, 2 by 1 matrix, 2 by 1 matrix. So rows and columns are very clear, easy to understand, and with the help of examples, and it is more easy than a definition. So next we see, as I already tell you, now we see importance of linear algebra, why we study linear algebra, and why we study statistics. These two, in this video, I explain two concepts. One is statistics. After statistics, definition of population and sample, parameter and statistics. And then we learn about linear algebra and linear algebra, rows and columns, matrix, and it's something else. So now we see the importance of why we study linear algebra and why we study statistics. So in this video, I learn about importance of statistic and linear algebra. Why we study linear algebra? So role of mathematics and statistics in machine learning. You know, today the era is full of machines, and we have to learn about machine learning. And machine learning, mathematics and statistics is very important. Without mathematics and statistics, machine learning is nothing. I will tell you which mathematics and statistics is involved and why. And you need to be confident the following subfields of mathematics. For the sake of learning about machine learning, and you have not need to go your high school lectures, mug up the theorems, and revise all the material of linear algebra and all the material of statistics, and learn of all these books and contents. It is very time taking. You, for the machine of learning, you have to be confident in some particular subfields of mathematics, and these particular subfields of mathematics include linear algebra. Linear algebra is in our top priority. Then calculus is also very important in learning machine point of view. So why we learn linear algebra? Why linear algebra is important? So because before learning anything, we have questions. And first question is, students, why we learn linear algebra? Why these, where these matrices use in our real life? Some students say in real life mathematics has no use, but mathematics has are huge and great advantages, and mathematics has its own magic. And when you see mathematics matter, you are amazed. You will be amazed. So linear algebra, it makes possible for algorithms to run on massive data sets. So linear algebra makes algorithms possible for their running. So linear algebra shows everywhere in the machine learning world. And in machine learning world, linear algebra is very important. So linear algebra everywhere in the machine learning world, and without linear algebra machine learning is nothing. So without linear algebra machine learning methods cannot be developed. A complex data and a complex data structure cannot be handled or manipulated. Matrix operations on large data sets are not possible. So that's why we learn linear algebra. Topics of linear algebra used in machine learning. In machine learning, linear algebra concepts, one need to know vector space, vector scalars, orthogonal normalization, matrix operations, projections, eigenvalues and eigenvectors. These are the main topics of linear algebra that are used to learn machine learning and very important. And we learn about matrices. Similarly, we learn all about all these topics of machine learning. So question is that why we study statistics? Because statistics and mathematics are very depend on each other and very important in learning some new technologies, learning new concepts. So statistics can be used to draw logical conclusions from the given data. Statistics helps to understand the data insights and transitions the sample observations into the meaningful information. So statistics, statistic is the science of measurements. Planning studies and can be used to draw logical conclusions from the data. And you know what is data? Data is raw facts and figures, and it can be measurement and anything. So statistics helps to understand the data insights and transforms the sample of observations into meaningful information. So that's why statistics is important. Topics of statistics used in ML. What is ML here? ML is machine learning. Topics of statistics in machine learning is distribution, central tendency, skewness, linear algebra, linear and correlation coefficient, central limit theorem. And central limit theorem is very important in statistics, and hypothesis testing. These are the main topics which we learn in statistics. So these are the definition of set, and we learn it already. Set is well defined and all this thing. So you need to know about why statistics and linear algebra are important, and how we use it in our machine learning and other point of view. So, as we discuss group theory and linear algebra, first of all, we see importance of statistics and mathematics in machine learning. Now, we will see some important concepts of linear algebra. In linear algebra concepts, we first of all we see basic definition, on which all other definitions depend, and this definition is binary operation. What is binary operation? I use this word binary operation in a group theory already, but in group theory I want to explain it more, because on binary operation all our group structures, ring structures, and in the next field structures depend. So that's why I want to explain about binary operations. A binary operation star on a set G is a function from G cross G to G. What is G? When we do not describe a group, all the group properties, then before that G is a set, nothing, it is not a group, it is a set. And set, you study about set of natural numbers, set of integers. I write it some important sets, and set of natural numbers, and I used here. What is set of natural numbers? Set of natural number is 0, 1, 2, and so on. Okay, this is our set of natural number, or set of integers. That can be any set of nature, and integers include 0, plus minus 1, plus minus 2, and so on. So these are the topics of these are the elements of, sorry, linear integers. So set of integers, set of nature numbers, and we have other sets, for example whole numbers, rational numbers, and for example whole number and rational number q. We This is q. So these are the some important rational numbers, important sets. So binary operation is a binary operation, g cross g. What is g cross g? G cross g is a Cartesian product, and Cartesian product that prime defines from g to g. For example, we have set and define an operation from set to itself, and our answer remains in that set. So this is the binary operation. For example, g if g is equal to n, for example, we see g is a set. So g is a set, then let's suppose our set is natural numbers, and binary operation is addition. Binary operation can be any operation. It is multiplication, division, but maybe division is not a binary operation, because for binary operation condition of closeness it must be exist. If our set under that operation is closed, then it is binary operation, and if not, then it is not. So natural number, set of natural numbers and cross and binary operation, and define addition on it. Addition, we write this addition in the form of this. First of all, we write plus in the parentheses and write the elements of n and n in pairs, because in Cartesian product we write elements in pairs. You know the definition of Cartesian product. In Cartesian product, I write here first element, then this is second element, and for all a belongs to a, our first set, and b belongs to our second set. Here first set and second set both are equal, and it is equal to g. So here am is also belongs to natural number, because here our natural number is set of group is set is natural number. So n is also a natural number, and sum sum of two natural number is again a natural number. So that's why addition is a binary operation on set of natural numbers. So see next. These are the mappings, and now we will learn one more example of natural number, but here we change the operation, and I want to show with the help of this example how when operation changed, how our results changed. Magically we got different results. For example, our set remains same, natural number, but our operation changed. In the previous example we have addition, but now we have subtraction. So in subtract or minus, m minus n belongs to n, but m minus n does not belongs to n. Here does not word is important. Plus are two binary operation. Here I explain this with the help of example on writing it here. For example, set of natural number, and set of natural number is this: 1, 2, 3, and so on. Okay, so this is the set of natural number. We defined a Cartesian product from set of natural number to natural number: 1, 2, 3, and so on. Okay, so from this set we have this in 1, 1, 1, 2, 1, 3, and so on. Write the elements in pairs. As our elements sets are infinite, so our Cartesian product is infinite. So from this Cartesian product we choose two elements and apply subtraction on it. Mean we choose 1 1 1 2 and apply this operation on it. And 1 minus 1 is what? 0. And you know nature number starts from 1. 0 is not belong to set of nature number. But according to definition of binary operation, our answer remains in that set which we our domain set. So that's why here natural number subtraction on set of natural number is not a binary operation. Here you see our set remains same but our operation change, so binary operation is also changed. So binary operation depends and vary operation to operation, maybe another operation satisfy or maybe another operation on the same set binary operation does not satisfy. So you have to see its closeness property of the set. If the set is closed in that binary operation, then it is and under that operation, then it is binary operation. On the set of real, now we see some important and common facts and which are proved and which are true. And we when we see these points and we clearly say without calculations and without thinking more about that, we clearly decide whether it is binary operation or not. In set of real numbers, you know real numbers is a very large set and it is very important in real analysis and group theory and linear algebra. So that's why on set of real numbers f of a, b, we have a plus b is a binary operation since the sum of two real number is a real number. So when you see a set and this set is real number, and you know definition of real numbers, in real numbers include all rational numbers and all irrational numbers. Union of rational and union of irrational numbers is the real numbers. So our real number is very large set and contains all the rationals, all irrational numbers. And you know in rational sum of two rational is a real number. So it is a definition or real numbers. And in real numbers under addition binary operation is always hold, and you have no need to verify it because it is already proven by its statement. So that's why on set of real number a plus b is a binary operation, and the division cannot be defined on real numbers. So this is also a common factor as like minus. In real numbers, division of two real numbers will not be a real number. This is because r cross r to r. What is r here? Here r is real number and r cross r the Cartesian product of real numbers. And what is I? I is the function, some function or some operation defined on real numbers to real numbers is given by a cross b to a by b. Now if we take b as 0 here, because you know 0 is included in the set of real numbers, and when we put 0 in instead of b, then it is undefined, because you know something divided by b is 0 is because you know when we divide something by 0, so it is undefined. Okay, so it means division is not closed because we 0 is a real number, 2 is a real number. So when we divide 2 by 0 is equal to infinity. Infinity is not included in real numbers, so that's why it is not closed. So division is not a binary operation. So you first of all you have to know which operation is a binary operation and which operation is not a binary operation. Then you have to decide more about it. So first now what we learn, make this sketch. First of all we learn about linear algebra, then we make sketch of I make the sketch of the whole lecture. First of all we learn linear algebra, then we will learn statistics and then their importance. Okay, then we move forward over topics of linear algebra and group theory. And in group theory, binary operation, as we defined already, binary operation is very important. So here we see some examples of binary operations and definition of binary operation, and see also some counter examples, and these counter examples help us to make some important decisions about group theory. So as we start from group theory, and now we see some important points that kept in mind every student of group theory student, because it is necessary to verify all these properties of groups, associative, commutative, and all other properties. But you have a clear concept in mind: the set of integers z, and plus is the binary operation, and z plus set of integers under this binary operation, set of rational number under addition, set of real numbers under addition, and set of complex numbers under addition are abelian groups. And similarly, q dot dot mean multiplication, set of real numbers, set of rational numbers, and set of complex numbers are not groups. Why they are not groups? Because they have identity, they include zero, but zero have no inverse in that set multiplication, because here our identity is one. Okay, so inverse of zero is undefined here. That's why when zero include in these sets, then these are not groups under multiplication. But when we remove zero, then we name it q star, and this q star is a group under multiplication. When we remove zero from q, then it become q star. When we remove r, zero from r, then it become r star, and it can be read as a set of real numbers without zero under multiplication, and set of complex numbers without zero under multiplication are groups, and hence abelian groups. What are the abelian groups? For abelian groups, you have to satisfy the commutative property with respect to abelian groups. What is commutative property? So in commutative property, when you multiply two terms, and for example, when you multiply, okay, one minute, when you multiply 2 by 3, answer is 6, and but when you multiply 6 by 2, answer is 3 by 2, 6, 2 by 3, 6, mean changing their position of the elements and apply the operation, respective operation is does not change result. Our results become unchanged. That's why it is commutative property. And in addition, multiplication, commutative property, and multiplication. And when we use see addition, when we use addition as a binary operation, then our commutative property named as commutative property under addition. And when we use binary operation as a multiplication, as a binary operation, so here commutative property under multiplication. So z dot is not a group. Z dot, when we exclude zero from z dot means set of integers under multiplication, then it is also not a group. Why? Because inverse of each element does not exist in it. For example, 1, 2, and 2 multiplicative inverse is 1 by 2, and you know in inverse 1 by 2, 1 by 3 are not included in set of integers. In set of integers, you just have discrete elements 0, plus minus 1, plus minus 2, and so on. So when we exclude 0 from rational, real, and complex, then it become a group under multiplication. But real number is in set of integers is not a group under multiplication when we include 0 or when we do not include 0. So these are the 4 important concepts and points of group theory that we kept in mind every time, and when we learn group theory and study about these topics. What we learn from here? First of all, we learn about set of group. Then we see set of integers, rational, irrational, and complex numbers are groups under addition because they satisfy all the properties of the group. And what are the properties of the group? Associative, inverse, and identity. And for first of all, see closeness. Is the given set is closed under that addition? After seeing closeness property, we see it is a associative law hold in it, identity element exists in it. With respect to that one, identity can be vary according operation to operation. So here is these are the some important groups, example of groups, and example of groups sets which are not good. When we study about groups, you have clear about idea of set because you choose one set and satisfy all the other properties on that set. Then if this set satisfy all the 3 or 4 properties of a group, then it is said to be group, otherwise it is a set. So first of all, you will learn about set, then you will learn definitely in a clear way about groups and their operations, about their domain, range, and other important concepts of group theory. So first I give one set and you can tell me what it is a group or not. Okay, so we discuss it already, but I want to give one more example. Set of nature numbers. What about set of nature numbers? Set of nature number is not a group. Why? Because under addition is not a group, because under addition plus is the identity, but set of nature number starts from 1 and it does not include identity. That's why set of nature number is not a group. What is the other reason? We have 2 reasons in which basis we say set of nature number is not a group. One is it has no identity element in it, because under addition our identity element is 0. So next other property that violates this set is inverse. When you have no identity, then definitely inverse and identity depends upon each other. So it has no inverse, and so it has no inverse, no identity element. That why set of nature number is not a group. Or think about set of matrices. Set of matrices is a group but not a billion. Or think other definitions of a group. Set, take some sets, make properties on that set, and define some binary operations on it and see it is a set or a group or not.